Good morning. How's it going with everyone today?
Good. How are you?
Good. I'm feeling like the weekends just keep getting shorter and shorter. I can't figure that out.
I agree.
Yeah, it's annoying, huh? All right. So happy Monday. I hope you saw that I went through your tests. Yeah, and I gave you feedback on your written work. So hopefully you're looking at that like I write on your paper. So make sure you take a look at that. And then I did do your grade. I am still contemplating. I know a couple of you, not many of you, um, ran out of time. Not all of you, but some of you. So I'm still debating what to do with those scores. So just think about that, keep that in mind. I'll be determining what I'm going to do with that probably today-ish. Overall, people did well. You know, you made some silly mistakes on some of them, maybe some conceptual mistakes on others of them, like you just didn't know how to do it. The most mistakes I saw were on the last problems, which I would say were the hardest sections on the test anyway, you know, that very last section. And what's interesting is what a lot of you did was, I'm not sure you understood to the right or to the left, or you didn't read it, right? And so some of that might have been a time issue. But or maybe you just didn't understand that section. So, but overall pretty good. One of the biggest mistakes I saw were on box and whisker plots. So on box and whisker plots, you can't just mark your number line underneath whatever intervals you can't have, okay, from here to here is 25 and then that same section next to it is 100. Like they have to be even intervals. Otherwise, your box and whisker plot isn't showing the spread of the data, which is what it's supposed to do, right? So you should have a number line underneath your box and whisker plot that's evenly intervaled in whatever interval you choose. You could choose 5, you could choose 25, whatever you want, but then that shows your box and whisker plot. So some of you, I think that was a misunderstanding. Jende, check on your speakers. Can everybody else hear me? Yeah. So Jende, check on your speakers. Use the little button on the lower left corner. It has a microphone. And if you click that, you should be able to test your speaker and your microphone. So see what speaker it's supposed to be coming out of. All right. So any questions for me about the test? Like in general, if you have specific questions, you can come to my office hours or have a meeting with me or ask me in the chat or something like that. But any questions in general? So that was our longest test. Our next test for probability, I broke into 2 pieces. So we're going to go through the first half of probability, like PC1 through PC4, and then we're going to do the second half of probability. So PC5 through, I don't even remember how many sections are in this, but anyway, you get the idea. So I think that'll be a little more digestible for you. Instead of a giant test, you'll have 2 smaller quizzes. Okay. All right. Did everybody do their reflection? I hope. I didn't look and see yet. All right, good. So the reflection is a time for you to think of how am I doing so far and what can we change to make sure I get back on track, right? If I'm not, or what do I need to do to stay on track? Because right now, this time of the semester is when people think, oh, the semester's too long. We go on spring break and then we don't come back. Yikes, don't do that, right? Whether we physically don't come back at all, like you don't even log on to class and you disappear, or you log on, but you're not really doing any of your work anymore. So your grade drops dramatically after spring break. So don't let that happen to you. And we don't want to lose anyone over spring break, right? Everybody's trying to finish. So make sure if you notice somebody has been missing, you reach out to them via Canvas, and say, where are you? Like, we miss having you in class. Like, what's going on? Right? Like, there's not enough of us. She's going to pay way too much attention to me if you don't come back. Right? So those little things, be careful of. But you guys, we need to finish strong. We need to get out of this class successfully, right? So we can move on. Yeah, you don't want this math class to be holding you back from the rest of what you're doing. Okay. Speaking of which, let's do a mindfulness Monday. Let me see if I can get this ready here. This is, I don't know. I'm going to share it with my other screen because I'm afraid you're not going to be able to hear it if I share it with this one. This is a breathing exercise. Let's see if I can find you guys somewhere on this mess of a desktop that I have. It's a true wreck today. All right. All right. So remember, during our Mindfulness Monday, you can turn your camera off if you want. I think this one is pretty short, but it's still a good one.
Close your eyes and rest your hands on your knees. Bring your attention to the touch of your body on your seat. Feel the weight of your body on your chair or cushion. Make sure that your back is straight and that you're comfortable. Take a few deep breaths. While you're breathing deeply, relax your shoulders, your stomach muscles, the muscles in your face, your hands, and your legs. Let go of all the tightness in your body. Now bring your attention back to your breath. Notice what it feels like as it enters through your nose, goes down through your throat, filling your lungs, and back out through your nose. Notice your stomach and chest rise and fall each time you breathe in and each time you breathe out. And just allow your breathing to be natural and relaxed. Now bring your attention to the feeling of your breath in your nose. Feel your breath as it comes in and goes out. Just focus on this sensation, paying attention to each time you breathe in and each time you breathe out. As you inhale, maybe your breath feels cool. And as you exhale, maybe it feels a little warmer. When your mind wanders, or if you become distracted, just notice what's going on in your head, and then gently bring your attention back to your breath, going in and out. Focus on the feeling of your breath and allow thoughts and feelings to come and go in the background. Now gently bring your attention back to the touch of your body on your seat and open your eyes.
All right. I hope you guys liked that one. I think that's a good one. It's very calming if that's your thing. And just these, hopefully throughout the semester, we'll show you one or two that you really like that you want to use, for yourself, to help you relax and stay motivated. I don't know about you, but even that time, I didn't even look at how long it was, is hard for me to not get distracted. I loved it when she said, if your mind starts to wander, I was like, oh, yeah, my mind already wandered. Like, I need to bring it back. So, we need to just be mindful of things. Did any of you meditate before the test? Any of you try that? No? It's okay. If you're doing fine and your scores are coming out the way you want, then don't change it, right? But if you're struggling or feeling like you're getting super stressed in the middle of the test, meditating before might really help you. Okay? All right, that is very relaxing. I agree, Jen Day. Okay, so now let's do a little recap of what we did last week. On Thursday with our, remember when we rolled the dice? You guys played that game? Yeah. We're going to look at the results of our game. Okay. And we're going to calculate something. So we're going to calculate experimental probability, which is what we did in our experiment. So remember when we put all our data in the spreadsheet? So now I'll share my screen with, I will put this in the chat and I will pull it up. We are going to calculate the percentage of each one of the numbers that we rolled on our dice. So for example, I took both my classes and I said, okay, what's the probability of getting a 1? Well, remember, we figured out it was impossible to roll a 1 when you're rolling 2 dice because the smallest number you're going to roll is a 2. So we rolled a total of 915 rolls between all my classes. Okay, so the chance of rolling a 1 was 0 divided by 915, so 0%. If I, hold on, let me pull up this doc. And what I want you to do is calculate the percentage for each one of these that we did. So if we look at the first one, how many 2s did we roll? We're in this first table. We rolled 31 2s. Do you see that? On that paper, 31 2s out of 915. So if we take 31 and divide it by 915, and then we make that a percentage rounded to the nearest tenth, what would that percent be? What would you write in that box? Anyone?
Is it 3%?
3, and then go to the nearest tenth. So go to 1 decimal place. It would be 3 point.
3.4.
There you go, 3.4%. Perfect. Does everybody understand how Olivia got that 3.4%? Yeah. Okay, so you want to do that for all of these. So calculate all those percentages. You can make your own copy. You can just jot it down on paper. It doesn't matter. We're just going to compare it in just a minute. So I'll give you a couple minutes to calculate all those, and then I'll call on you and we'll make sure, because a lot of us had rounding issues on the test. So we want to make sure we know how to round things. Okay. All right. So we were just doing theoretical first, but we are going to do experimental as well. I mean, experimental first, then we'll do theoretical in just a minute. So for how many threes we rolled or what percent of threes we rolled, did you get 5.9%? Yes, excellent. All right, for fours, Amanda, what did you get for 4?
Uh, 82%.
I like your digits. I'm not sure your decimal's in the right place.
8.2%.
There you go. 8.2%. Didn't that sound, as soon as you said it, you were like, wow, that sounds a little high, right? 82% of the time we rolled a 4, we would be amazing. I would be concerned about loaded dice at that point, right? All right. How about 5? Aaron, what'd you get for 5s?
10.1%.
10.1%. Is that what everybody got? Questions on rounding or anything, make sure you ask me, okay? How about for 6? Angelina, what'd you get for 6?
14.1%.
14.1%. Excellent. Yesenia, 7s?
16.4%.
16.4%. Is that what you guys got? All right. How about 8s? Olivia, what'd you get for 8?
I got 12.9%.
12.9%. Is that what everybody got? Very nice. And 9s, AJ, what'd you get for 9s?
I got 11.5%.
Very nice. 11.5%. And for 10s, Ashley, what'd you get?
I got 8.7%.
Very nice. 8.7%. Amari, what'd you get for 11s?
4.9%.
Very nice. And 12s. Valerie, what'd you get for 12s? And go ahead.
Oh, hold on. I stopped at 10.
Okay, so do 12 right now real quick. It was 36 divided by 915.
$3.9%.
Perfect. 3.9%. All right. So good job. Any questions on rounding on those? Okay. Now on the numbers on the bottom, you might be wondering where those came from, for those theoretical probabilities. So I'm going to show you where these numbers came from. So if you look at this document, do you agree, and I can put this in the chat for you as well, do you agree that these are the possible outcomes? Like on dice 1, like if I call this dice 1, then my possibilities are 1, 2, 3, 4, 5, 6. And if I call this part dice 2, then my possibilities are still 1, 2, 3, 4, 5, 6. So this table shows me all the possible outcomes if I write the sums in here. Does that make sense to you? So for example, I thought I had, oh, here we go. Here's this doc. I was like, wait a minute, where's this document at? So in case you want this picture, I'm going to put it right here in the chat for you. And we could fill in this table. So if I have a 1 plus a 1, I'm going to write a 2 in there because 1 plus 1 is 2. And then 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. 1 plus 6 is 7. Does everybody see how I filled out that table? Okay, so let's fill in the rest of these. And then you'll see where I got those numbers from on the other slide. So if we go across the second row, 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. And 2 plus 6 is 8. Everybody okay with that? Okay, so somebody want to tell me how to fill in the next row across?
Wouldn't it be 3 plus 1 is 4, and then 3 plus 2, 5. 3 plus 3 is 6. 3 plus 4 is 7. 8, and then 9.
Very nice. Perfect, Olivia. Everybody seeing how we're doing that, right? Nice. What's the next row across? Just read me the answers.
5, 6, 7, 8, 9, 10.
Very nice. And the next row?
6, 7, 8, 9, 10, 11.
Yeah, Jen Day's like, I see a pattern here for sure, right? How about the next one?
7, 8, 9, 10, 11, 12.
Yay! Okay. Now, what we do, and you could probably see that pattern when you're filling it out, which is kind of nice. But now you want to fill out this table down here at the bottom, and you say, okay, we knew that there were no ones possible, right? And then twos, if you look at twos, you just see there's only 1, 2 right there. Yeah. And then if you look at threes, you can see that there's 2 threes. Fours, you can see that there's 3 fours. Are you seeing this pattern as well? Now, don't get carried away with the pattern, right? Like, don't go too crazy. What would be the next number for fives right there?
Four.
Yeah, because there's 4 fives. There's 4 different ways to make a 5, a sum of 5 when you roll 2 dice. That's what this is telling us. Okay. And you can see all the combinations. You could get a 1 and a 4. You could get a 2 and a 3. You could get a 3 and a 2, or you could get a 4 and a 1. Those are all the possible ways to roll a sum of 5 with 2 dice. Okay. Now, on sixes, you can see it's here on the diagonal as well. So there's 1, 2, 3, 4, 5 ways to make a 6. Then when you look at sevens, there's 6 ways to make a 7. And then notice when you get to eights, it starts going back down. Did you notice that? So then it goes 5, 4, 3, 2, and there's only one way to make a 12 right here. Yeah. So you can kind of see what's happening to that. Now, how many total possible are there? There's a total of 36 possible outcomes. Where did I get 36 from?
You added all of them. That's from the dice.
Yeah, well, I looked at how many possible outcomes there are, and notice this is a 6 by 6 grid. And so 6 times 6 is 36. Or if I counted all of these, I would get a total of 36 possible outcomes. Okay. Everybody making sense of that? You seeing where I got that 36 from? Excellent. So now if you go back to that table, you can calculate those other probabilities. So go back to this document right here and calculate the percentages, round them to the nearest 10th again. After you do all those, compare them to our experimental, right? So obviously this is going to be 0%. 1 divided by 36. If you do that on your calculator, and again, you round to the nearest 10th, you're going to get 2.8%. So when you compare that to ours was a little bit higher. We had 3.4% instead of 2.8%. Okay. So calculate all of those, and then we're going to talk about them. And again, type to me in the chat when you're done. All right. Did you guys finish? Are you close-ish, I hope? Yeah, give me something. Give me a thumbs up. Give me a head shake. I know some of you told me you were. Okay. Excellent. Okay. So when you filled all these in, you probably noticed something. So let's confirm. Did you guys get 5.6%, 8.3%, 11.1%? This is for your theoretical. 14.9%, 16.7%, 14.9%, 11.1%, 8.3%, 5.6%, and 2.8%. Everybody okay with those? Is that what you got for your theoretical?
I got 13.9% for 5.
I got 13.9.
That's what I got too.
Oh, maybe I was typing crazy in my calculator. There we go, 13.9%. Thank you, Aaron and everyone for confirming that. Everything else okay? Yeah, all the other ones are good? Okay, now, so some of you were already comparing some things. Most of you noticed that the highest percentage was in the middle, right? So it started off on the ends really low, and then it increased towards the middle, and then it tapered back off. And if you notice, like our percentages for 7, ours was 16.4. The theoretical probability, just counting the possible outcomes, is 16.7. That's not very far off, considering we didn't have very much data, right? So, and then notice some of ours are a little bit higher, some of them are a little bit lower, but overall they're pretty close, right? And some of you might be saying like shockingly close, right? Like surprisingly close. Yeah. So, and what you might be noticing is in our theoretical probability, I love this picture with these dice. So you can see, does anyone notice that this kind of looks like that bell-shaped curve we talked about in statistics, where it's real high in the middle? So most of our data is clustered between 6 and 8 right there. And then it tapers off to the end. So 2 and 12s were pretty rare. So if you were going to play this game again, where would you put all of your cubes?
6, 7, and 8.
Yeah, probably 6, 7, and 8, right? Does everybody understand why you'd put your cubes in 6, 7, and 8? Because those are the most likely to come up given their outcomes. Now, you could still lose, right? Because it's still probability. There's still a chance that the other person, maybe they just rolled some 11s and they just happened to have their cubes on 11 before you rolled something. When I was playing the other day with a student in another class, I think I had 2 cubes left on 5. And I could not roll a 5. I rolled 7 after 7 after 7 after 7, and I was getting really annoyed. So I should have just put more of my cubes on 6 or 7, and I would have been more likely to win. So the idea behind this is experimental probability is calculated by doing an actual experiment, rolling dice like we did, right? And collecting our data and putting our number of outcomes over our total and then getting our information. But for theoretical probability, we didn't have to do an experiment at all. We could just look at these possible outcomes and calculate it, right? So, and what's interesting is when we do an experiment over and over and over and over again, our actual results will get closer and closer and closer to our theoretical probability. That's called Bernoulli's theorem or the law of large numbers. So, for example, if I asked you all to flip a coin 10 times, right, you might flip 7 heads and 3 tails. So your experimental probability of getting heads would be 7 out of 10, and your experimental probability of getting tails would be 3 out of 10. But if I asked everybody in our class to flip a coin 50 times or 100 times, and then I put all of our data together, we would get really, really close to our theoretical probability. Which, what is our theoretical probability of getting a heads when I flip a coin? Anyone know?
Is it
What is
50.
it? Yeah, 50% or 1/2, right? Because there's one head out of two sides of the coin, or half of the time, 50% of the time, I should get heads. Yeah. So, and you can do these experiments like literally flipping a coin, or you can flip a coin like electronically. There's some, just like we rolled our dice electronically, you could flip a coin electronically and you could record those results. So theoretical and experimental probability are different, but when we repeat an experiment over and over and over, we get close to the theoretical. Any questions on that? All right, let's get this one ready in the chat. Suppose you roll one 6-sided die. What's the probability you roll a number bigger than 2? Bigger than 2. So get your answer ready in the chat, but don't hit enter yet. And you could put your answer as a fraction, a decimal, or a percent. Doesn't matter to me.
Can you repeat it again? The bigger than a 2?
Okay, can you not see my screen?
Oh.
Yeah, the probability of rolling a number bigger than a 2. I just wanted to make sure I was still screen sharing. I thought maybe it timed out or something. Everybody have it ready in the chat? Okay, 3, 2, 1, enter. Excellent. And I love the variety, by the way. I like that some of you put a simplified fraction of 2/3. Some of you put the original fraction of 4/6, which is fine in here in class. Just know if you put it on more is going to say it's not simplified, right? So, but you're fine. 4/6 is equivalent to 2/3. And then some of you put the percent, 66.7%. Excellent. Very more and I will always ask for simplified. Yep. Yep. Okay. How about compute the probability of tossing one 6-sided die and getting a 7? What's the possibility there? Get it ready in the chat. The probability of getting a 7 when you toss one single 6-sided die. All right, 3, 2, 1, go. Yeah. You're like, is this a trick question? What's happening here? Right? Isn't it 0? Yeah, it is 0. And Angelina, perfect. 0 out of 6 is true. Again, if more asks you for simplified, you would just put 0. But I like to see that 0 out of 6 because I can see your thinking. So that's not incorrect when we're doing this in class. Okay. And there's our answers, just like we just went over. Let's look at this one. This might be a little bit trickier if you don't know some things. So it says, suppose you write each letter of the alphabet on a different slip of paper and you put the slips into a hat. What's the probability of drawing one slip of paper from the hat at random and getting a vowel versus a consonant? So first, let's go over a couple things. Do you know how many letters are in the alphabet? Anyone?
36.
How many?
36.
Close. There's a 6 in there.
26.
There you go. 26. 26. So A through Z is 26 letters. So there's 26 total letters. When I say a vowel, what do I mean?
A, E, I, O, U.
Yep. A, E, I, O, U are our vowels. We're not going to worry about sometimes. Okay. So we're just going to do A, E, I, O, U. Those are our vowels. What's a consonant?
Like B, C, like.
Yeah, not a vowel. right? Anything that's not a vowel is a consonant. So now you should be able to answer these two questions. Okay. So you can get them ready. You don't have to put them in the chat. I'll just call on you randomly. So I'll give you about, I don't know, 45 seconds to think about it. All right. Who wants to answer the first one? What's the probability that you're going to get a vowel?
Um, 5 out of 26.
Very nice. 5 out of 26. Did anyone make it a percent or a decimal?
13.9%.
How much did you get?
13.9.
Did anybody else get 13.9?
I got 19.
19.2.
19.2. So did you do, I think, Valerie, you might have divided by 36 instead of 26.
Yeah, that's probably what I did. Sorry.
Yeah, so make sure you divide it by 26, not 36. And then the probability of a consonant?
21 over 26.
Very nice. 21 over 26. And if you divided that on your calculator, you would get 80.1% or so. Yeah. Now, these totals should sum to 100%, and they don't right now. Why don't they right now? Why was it not perfect? I mean, 5 over 26 and 21 over 26 sum to 1, but our 19.2 and our 80.1 don't. Oh, because first of all, this should be 80.8.
In order to make 100, don't you have to be like, it has to be like 26 divided by 26 in order to make 100?
Yeah. Yep. So if we add 5 over 26 plus 21 over 26, we're going to get 26 over 26. But sometimes when we round, it's not exact. So be careful on your percentages, right? So it might not be exact when you do your percentages. All right. So I'm going to let you guys practice in a minute. I think this is the first question on the practice sheet, but let me look. Six red balls, 2 white balls, and 5 yellow balls. Yes. Okay. So I'm going to put this in the chat for you. This is what I'm going to have you work on in some groups. Okay. And you can help each other. So if you look at the first question on that worksheet that I just put in the chat, it's the same as this question right here. A ball is drawn randomly from a jar that contains 6 red balls, 2 white balls, and 5 yellow balls. Find the probability of the given event. So when we do that, any ideas on what we need to do?
It's mentioning the red ball.
Mhm.
So it'll be 6, and then you add 6, 2, and 5, and that's 13. So it'll be 6 over 13.
Very nice. So it'd be 6 over 13. Does everybody see where we got those numbers? Yeah, and you could write it as a decimal, which is 0.4615. Usually if we go to decimals, we're going to 4 decimal places. And if we go to percent, we're going to write 46.2% because we usually go to 1 decimal place. Okay. Then a white ball, you would do 2 over 13, which would give you 0.1538 or 15.4%. I'm going to put you in your groups now. And if you look, the next one is about cards. And I gave you a deck of cards. How many of you know a deck of cards already? Like you're familiar with a deck of cards? Like you know how many diamonds, how many hearts, how many spades, how many clubs? Not all of you do. Some of you do. So if you need this deck of cards handout, I don't think it's on that worksheet, is it? Oh yeah, it is. Good. It's on that worksheet so you can see the picture. So it will help you. All right, I'm mixing it up today. I'm going to put you in random breakout rooms. Okay. I don't know how many there are. How many we have in here? It always puts my iPad in a room, which is a little annoying. All right, so I'm going to open your rooms, work on this. If you're done or struggling, call me in for help. Almost everybody's back. I'm just going to wait till they get back. All right. So good job today. I know you didn't get through the whole thing. You can if you want. It's great practice. I'll post my slides and the key is in the slides for you. So you don't have to worry. You're not turning it in or anything. But I did want to show you that for like a problem, if you're having trouble simplifying, I know some of you had like 4 over 52 is that what you guys had? No, maybe you had 12 over 52 for like how many face cards are in a deck, right? And so apparently I can't type. So, and it gives you the percent, but on the Desmos calculator, if you just hit this little fraction circle, it gives you the simplified fraction. Do you see that? So if you're having trouble simplifying fractions, the Desmos scientific calculator is very, very helpful. So if you just put in the fraction, then it'll give you the decimal, but this little button right here on this far right will give you the simplified fraction. Okay. Okay, so I have 2 exit ticket questions and I want to make sure you get to them. Whoops. And so take your time, read the directions because it'll mark you wrong if you don't put it in the correct format. We're going to start PC2 tomorrow. So you need to do your mini lesson for PC2 tonight. Also do your practice, which is the PC1 practice. Okay. So, and don't get behind on your homework because it's really hard to catch up and those points add up pretty quickly. Okay, so here is your exit ticket if you didn't use the QR code. All right, good day today, and I'll see you tomorrow. You don't have to stay on here to finish the ticket if you don't want to, but you can.